Well, hello there. Welcome to the introductory video to our next unit of study, which is, as you can see on the screen here, a study of motion. Now, that's a pretty general idea, right? We're going to get into some aspects of motion that are probably a little different than what you've ever studied before. You're all familiar with motion. I mean, you do it all the time. You walk around, you might get on a bike, you're in a car. That's all considered motion. In fact, you live on a planet that is spinning all the time, although you can't really sense it, and also orbiting quite fast around the center of the solar system, the sun. So we live with motion all the time. And there are a lot of jobs that are very dependent on a good understanding of motion. Think about a lot of engineers. Like, for example, there are traffic engineers whose job it is to design traffic lights and stop lights and just the whole system of that, the timing of those things so that we don't get traffic jams or dangerous intersections. We have civil engineers who might design highways for safety. We could have aerospace engineers, and they're looking at bigger things like how do we get a rocket to lift a craft up to Mars? Or, just something as simple as an automotive engineer. So all kinds of people are working day in and day out, dealing with motion. Okay, so we're of course going to deal with some of the simpler aspects, I think. I'm going to throw you some terminology that you've probably not heard before. In fact, starting today, I want you to understand the difference between the word distance, which is something you're probably familiar with, and the term displacement. This is something a little bit more specific to a science class. So we're going to start with that, give you a little practice with distinguishing those two terms, okay? So I don't think I need to define what motion is. I think everybody has a sense of what that is. So let's start with those two terms, distance and displacement. So they're very similar, but they're not identical. So that'll be kind of our heading for today. Now I'm going to draw a little diagram that I think will help you to understand the two terms that I'm having you distinguish here. Let's do that first. So I'm going to describe the path that somebody might take if they're on a walk. And we might imagine maybe you're in a big city, you're in a downtown in a big city, and the streets primarily in big cities run east, west, or north, south. So let's just imagine somebody starts here. I'm going to put a little S here for start. And they start by going 5 blocks north. Okay, so you see how I represent that? So that's 5 north. Okay, we draw north up on the paper. And then maybe they turn and they walk 8 blocks east. East would be rightward on the paper. Now I'm drawing it so that my 8 is definitely a little longer, about 1.5 times as long as the 5. You don't need to be perfect. You don't need to use a ruler or anything. Sometimes we may work on grid paper to help us out a little bit. And then perhaps you turn again and you walk south. And let's imagine we go 9 blocks south. That one I was kind of careful about. I actually counted the lines on my paper, so I went 5 up this way and 9 down that way. And then maybe another turn, and we go 4 to the west, okay? And that will be where we end, okay? So we got our starting point, and we got our ending point. So maybe somebody asked the question, well, how far did you go? There's actually 2 different answers to that in a science class. And I want you to know the 2 different answers depend on whether you're asked distance or displacement. So let me describe each of them. You can write them down, and then we'll go back and figure out what the distance and the displacement are for these here. Okay, so the distance, this is the one I think most people are more familiar with. I'll describe it this way. This is not like a glossary definition, but a good description for you to understand it. It's a total accumulated length of the path taken, regardless of direction. That means direction doesn't matter. You're, of course, always welcome to pause, slow down the video if maybe it takes you a little longer. Maybe you're still drawing that diagram up there. If I go too fast, that's the beauty of watching this on video. You can slow me down, you can pause me. Okay? So, in our figure here, the total accumulated path. This just means add up basically all the steps that you took. It doesn't matter which way you went. This would be like, how far your legs moved if you have a little step counter on your phone or on a Fitbit or something. So remember, we measured in blocks here. I didn't write the units down because I just thought it would take up a little too much space. But this could be in, if you're an ant crawling along the paper, maybe it's in inches or centimeters. If you're just walking around your house, this might be in meters or feet or yards or something. So if we started here, we went 5 and another 8, that makes 13. 9 more, that makes 22. And then 4 more makes 26. So in our figure, 26 blocks was the distance covered. Okay? So what's another question we could ask? See if I can squeeze it in here. It's called displacement. Let me describe it this way. The length and there's something else involved, direction of the line from the start to the end. So the length and direction of the line from the start to the end. So we sometimes say as the crow flies, that means a direct line. So if we weren't stuck going east, west, north, south in the middle of a downtown, but maybe we could walk directly there, it'd be impossible. We'd have to walk through buildings. But what would that length and direction be? Okay, let's figure that out. A little math involved here. So I'm going to draw that line on our paper here. So we go from start to end. Okay, I'll do it in red so it shows up a little bit better. And that little arrow right there represents what we call the displacement of this path. Just the line from where we started to where we ended. Okay? So how long is that? And what direction is that? Those are the two parts that we need to know. Well, first we got to figure out, based on how we walked, just where we are here. So notice in the path of our walk, we had gone 5 north, but later went 9 south. So that tells you end up 4 blocks south of where you started. So I'll draw little dashed lines here. You could imagine maybe if we were in this downtown city, gosh, it would have been a whole lot quicker just to walk south and east rather than walk north, east, south, and west, right? So that's 4 blocks right there, 4 blocks south. And how far to the east are we? Well, we had walked 8 east, but then we walked 4 west, kind of undid 4 of that. That means we're also 4 blocks east of where we started. So 4 this way and 4 this way. Now that's not our answer yet. 4 is not the answer, and 8 is not the answer. The answer is something you learned to do in math class. I don't know when. Was it this year, maybe previous year? It's finding the side of this triangle. We call that the hypotenuse. And you have to use a little bit of math called the Pythagorean theorem. I don't have any more space to write it here, but I'm going to show you the length of the path, or the length of the line, not the path. The path was that entire path that was 26 blocks, right? So here's how we do this. We take the square root of the sum of the squares of the legs. You remember that Pythagorean theorem? So here's how we do this. 4 squared plus 4 squared. And then we square root it after we add them together. All right? Or, you don't have to write all this out. I'm just helping you. Desmos or a calculator could do this for you. I just don't want anyone to get lost. Like, where are these numbers coming from? Now, I grab my phone. You can maybe use a calculator or Desmos or something. Oops. So this final number here, let me see what it was. I believe I remember. Yes, 5.7 blocks. 5.7 blocks, okay? So that is the length of that displacement in our figure. 5.7 blocks. Now, here's something that you'll often forget. We also include a direction, okay? Now, I'm going to keep the directions pretty simple for you to do. In a later science class in a couple years, you could get more involved here, but I will always have it so it's easy to describe. Notice we went just as much south as we went east, okay? South and then east. So we can say 5.7 blocks southeast, and just write it like that. It might be northwest. If we had started here and ended here, it would have been northwest. Okay? So any of those, what we call cardinal directions, east, west, north, south, some combination of those is quite possible. All right? So obviously 26 blocks to get there, and yet we only ended up 5.7 blocks from where you actually started. But again, that's the hassle of moving around in a downtown area where you are stuck, staying on the sidewalks and on the streets, right? Okay, so there's a good example. We'll practice this a little bit more. The math that you need to do will not be any harder than what I had you do here. It's called the Pythagorean theorem. If you need a little review with that, maybe a classmate remembers how to do it and it can help you, or a teacher will be able to help you as well. Okay, don't be afraid to look that up on the internet too if you don't remember how to do a Pythagorean theorem. Okay, all right, so that's it for now. Make sure the notes are all done, and then we'll move on to some practice. Thanks for watching.